Hi, and welcome to the a16z podcast. I'm Hanne, and today's episode is about a pretty universal topic, which is the idea of longevity. And by that, we mean everything from increasing the amount of time that we're healthy to increasing our lifespan and even combating aging. We cover everything from the latest research to tools for what we can do in our own personal lives. This episode is based on a conversation at our Summit event in November 2017 and includes Jeff Kaditz, CEO and co-founder of Q.Bio, who's the first voice you'll hear after mine, Mike Snyder, professor and chair of the Department of Genetics at Stanford, the second voice, David Sinclair, co-director of the Glenn Center for Biology of Aging at Harvard Medical School, and Kristen Fortney, CEO and co-founder of BioAge.
This is a question I'd actually like to ask all of you, which is why now? Why is this the moment in which we can either find disease before it occurs or actually extend our lives? What is it that's setting the stage for this?
I think it has to do with the explosion in technology we have to measure biology. Because in almost any area of scientific discipline, the first step is kind of turning it into more or less an information science. And once we have enough information and we can start to model these complex processes, which are traditionally, thought of as being too complex for us to understand, but with the tremendous gains in computing power we have and the amount of information we can now measure about biology, it's starting to become tractable.
There's kind of two aspects going on. One is extending health span, and the thing that David works on is actually trying to reverse aging. They're somewhat different. They both have the same goal of extending people's lives. 40% of Americans will get cancer, and that number is only going to go up. So what you want to do is prevent that from happening, and we can now catch this much earlier with these new technologies, with biomarkers, hopefully, that will come out of some of these new ventures. And so if you can catch it early, you can actually then treat this before it happens, and ideally treat it in a personal fashion, and that will extend people's health span. They will live longer lives, healthier lives, we hope. And there are analogies for that with heart issues as well, another leading killer. Those are the two major killers of people in the country. So I think if we can catch these things early, which I think we're capable of doing now with new measurements, we can extend people's health span pretty easily. And it's already a reason why people are living much, much longer than they used to because of this.
What does the simple biomarker have to do with the aging process, and how did you start down that path?
Yeah, a real biomarker has to predict the future. That's how I think of a biomarker. So we focus on BioAge at finding molecular signatures of aging. And what I mean by that is it's something that we can measure in your blood that predicts basically your future. And we can measure about your body that says, what's your life expectancy? Are you at higher risk of getting heart disease in 10 years or Alzheimer's disease? We focus on mapping out these signatures using modern genomic technologies like the proteome, the metabolome. And then we look for modifiable risk factors. So they're useful not just as biomarkers, but potentially as novel targets themselves to interfere in the aging process.
And where did those biomarkers come from?
We want biomarkers of all-cause mortality. We want something that predicts future mortality. And I could go out and measure all your blood samples right now and then wait 30 years, and then I'd be able to predict mortality. And that's not going to work, right, for a startup. So what's really key for us is to partner with biobanks. And there's a lot of these, especially in European countries with socialized medicine systems, where they have like tens of thousands of samples in the freezer that are 10 or 20 years old and full electronic health records for those people going forward into the future. So we can take these samples that are 20 years old and we can query them with all the modern technologies and measure hundreds of thousands of variables and then integrate that with their electronic health records to try to predict their future health course. And that's where all our discoveries have come from so far.
So David, you've worked across a large number of startups in this area. What is the kind of breakdown of the tools that we're starting to see actually help us with aging?
Well, there are three main areas that I'm seeing really explode in the field. First of all, there's addressing the actual causes of aging, and there are many of those. Then the second area is harnessing the body's natural defenses against aging, which we've now known for about 20 years, initially from little model organisms in yeast. Mike and I used to work on that stuff. And now we're seeing the improvement of healthcare. This is, it's a theme at this conference, but the ability to predict diseases before they actually take hold. And those three combined, I think, are going to dramatically increase human health span and lifespan by somewhere between 5 and 15 years in our lifetimes.
We're entering an age, it started with genomics, of what we refer to as multi-scale biological digitization, and multiple scales both in length and in time of processes, right? So molecular processes happen on a length scale of about a billionth of a meter in very short time scales, and then we can measure things like cytomics on the scale of a millionth of a meter. And then we have technologies like biomedical imaging that's more of a thousandth of a meter. And as we're able to capture more and more of a snapshot at multiple scales, both in time and length scales, that's ultimately going to lead to multi-scale models of biology that can be used for prevention, not just measuring, but modeling in a personalized way the trajectory of somebody and personalized treatment.
We've all heard a lot by now about this idea of precision medicine with these new sources of data. What does that actually mean for increasing our healthy time in the immediate future?
Well, precision medicine is based on the premise that we're all different. We all have individual baselines and such. And I would argue the related field, by the way, is precision health. So trying to keep people healthy based on their individual characterizations. So, precision medicine at some level has been around for a long time, at least personalized medicine. But what's different now is the fact that we can collect data at a level that's never been possible before. So you can try and understand at an individual level what it means to be healthy and how people will respond to treatments for disease and such. And so I think coming back to the longitudinal aspect, by following people over time, at an individual level, you can see differences in people and catch disease early when it happens, try and keep people healthy based on the personal signatures, and then catch disease early and treat them based on their personal and precision characterization. So do very precise treatment. Kristen doesn't know this, but I actually have a personal aging marker because I've been following me for 8 years, and it may be actionable. I don't know. We'll see.
How does precision medicine, precision health, how is that going to change in our actual experience of the way we get treated or be healthy or preventative medicine? I mean, is the physical going to be the same as it is now? Is that going to change?
I think the way we do medicine now is totally Byzantine. It's just really ridiculous how crude we are at what we do. I mean, how many of you have had your genome sequence or exomes out there? A few. I think 10 years from now, everybody is going to raise their hands, right? That's going to just part of healthcare. And then to me, that's only just the start of things. I think we're going to collect lots of other measurements, and there are just some amazing technologies out there that should lead us to be able to do this. And as a study we've been running on 100 people, we've actually caught at least 2 cases of heart issues early because we were following them closely. In one case, right from simple wearable device. We also caught a pre-cancer and a case of early lymphoma by, again, just careful monitoring. Those are few of many examples just by following people with these kinds of new measurements. So I think that will become the norm in the future. At least we would like to make it. It's all just starting to commercialize now, I would say. But it will be, an integral part of healthcare.
How about for aging? What are the kinds of tools we'll start to see that we might see in our lifetime that actually prevent aging?
Well, often people are surprised that there are already molecules in human trials already. A couple of companies that I work with have been doing trials for a number of years now, and they seem to be working as advertised, but it's pretty hard to actually show that they're reversing aging. So we're going after particular diseases. But some of the approaches that are really new, that are really exciting, is addressing causes of aging. One of the main causes that's emerged recently are senescent cells that build up in the body. These are zombie-like cells that take themselves out of the cell cycle. They're not dividing, but they cause havoc. And there's new technologies emerging to be able to delete these cells with either small molecules or other approaches. And if you do that to a mouse, they seem to be rejuvenated. And the hope is, of course, that'll happen with us as well. More on the cutting edge, we were talking about information in the body. My personal view is that we have 2 types of information in our body. We have the digital, which is the DNA, and the analog system, which is the epigenome, how those genes are read out. And that's becoming more and more popular as an idea. The challenge, though, if it truly is epigenetic and analog, that's really hard to correct and not cause havoc, not cause cancer. But there are new tools. There is actually evidence in a mouse that you can reverse some of those so-called epigenetic analog changes with aging. And that's truly the next frontier in my view, because that really could lead to true aging reset. And you just go to the doctor every 5 years and get a complete reset or, almost complete reset.
I think there's also a little bit of dogma in medicine that you shouldn't run tests or take measurements on people that are asymptomatic. By the time you're symptomatic, a lot of times it's too late.
Yeah.
Right? And so we need to get to a place where we know well before you're symptomatic that there's a problem.
Right.
And then, there's a lot more options as far as intervention and treatment.
In terms of the system, though, are we set up? So who pays to keep us healthy? How do we incentivize the system?
As the cost of these measurements go down, at some point, I think it will actually be more economical to prevent these things than to sit back and wait.
I mean, we have proof of principle already for cholesterol, right? That's used as a surrogate marker of a pre-disease state. and it can be used as an endpoint in a clinical trial as well. So I think this sort of thing can certainly work with the current healthcare system. It's just a matter of finding newer and better markers, and that's what these sort of technologies are enabling.
But the key is to show proof there.
That's
always the limiting step.
Or combining
That's
them.
right.
The clinical trial or clinical
It's a long
studies
process.
are designed to isolate the information value of a single variable for predicting a specific pathology. But imagine if Google tried to give you search results based on a single parameter. They use millions. We should be using millions of inputs to determine what is wrong with you and what is the prognosis and diagnosis. And as we have these longitudinal, models that is complex sets of variables over individual time series and deltas, I think the precision is going to go way up.
I'll tell you a personal example, which is that I actually caught my Lyme disease early. And one reason I could do that is because I knew what my baseline measurements were. I had all the data. I knew from my smartwatch, from a simple pulse ox, because my blood oxygen was running low and my heart rate was elevated on these simple devices. That's one example that told me something wasn't right, which I then got treated and cleared it all up. But that's one simple example, and I think we just need to do that at scale with other kinds of measurements and other sorts of things. I knew the deviations from the data, and so I could catch it because I knew what was going on. And we need that for everybody, basically.
How do you think about who owns these big pools of data? How do we think about privacy and who has ownership over these streams?
I mean, I think we all should own our own data. Now, it's easy to say. It's not always easy to execute because a lot of providers think they own the data and such, and that's where a little bit of a tug of war comes in. We'll see how this all plays out. But I think in the end, you should own your own data and should be able to share it with others. Now, how to interpret the data is still tricky, and that's why there's a lot of opportunity out here and how to capture the data, get meaning from it and such.
How about the societal considerations? What will change if we end up spending lots more decades healthy or adding more decades to our lives?
Well, frankly, right now, 3/4 of annual healthcare costs go towards chronic diseases in the elderly, and those are years of sick life. So if we could really compress morbidity to the extent that we already can in mice. I mean, we have a lot of different treatments like senescent cell removal, which David mentioned, rapamycin, metformin probably too, that already work in mammals. And if we can bring these to humans, and I think that's going to be really wonderful from a societal perspective. Yes, probably the age of retirement will shift, et cetera. But I mean, who doesn't want a decade of extra healthy life as opposed to a few more months of sick and chronic disease?
It should, if you think about it, should make the economy more efficient. It's relatively expensive to educate a human and make them a productive member of society. If you get more years of productivity, it's actually a better ROI, right, for society as a whole.
Yeah, well, there are whole academic theses on this, and so the economists have calculated that just reducing one major disease, let's say cancer, by just 10%, the US would save about $3-4 trillion in the long run.
Wow.
And what we're talking about here is much bigger than that.
That's right.
And that's money that can be put back into education, the environment. And so we see a very bright future, not a land of old people in nursing homes, but vibrant 80, 90-year-olds that aren't taxing the healthcare system.
The name of the game is keep people healthy, then boom, off they go. So that's really
that's how it should
where
go.
we're heading. And actually, if you look at these supercentenarians, that's basically what happens to them. They live incredibly healthy lives. They don't have many chronic diseases. And then suddenly they just pass away. And everybody says, that's great. Look, they were healthy all the way to the end. And that's kind of what we're trying to achieve for everybody.
And in mice, it's not that hard. These days, if you extend the lifespan of a mouse 10, 20%, people say, yeah, what's new? And these mice, you look at them in the cage and you can tell the difference between the controls and these other mice. They're running around. The other mice are shivering in the corner and all grey and ragged. But then they die quickly, these long-lived mice. It's a relatively quick death. I think we can achieve that in humans. There's no reason why we can't.
Since I'm not a mouse, what can I do to actually increase my age, my lifespan, or my health span so that my picture looks like that? So I just keep going and then stop.
Exercise and eat your vegetables. Drink lots of caffeine. Very robust results with all-cause mortality there, and baby aspirin, and probably metformin, in a few years.
I was going to say exercise and eat your vegetables too, but we hope to change that. Many of you have 400 sensors on your car, and it's measuring you all the time. And the average number of sensors on a person is 0. And you think about it, that's crazy, right? We should be following ourselves much more carefully. And we can do this with these new kinds of measurements we've talked about and follow ourselves the way we keep our car running, keep our bodies running the same way. And so in the future, I hope that's what we'll have.
The area that I get asked a lot about is harnessing the body's natural defenses against aging. We all know that if we exercise and we diet and stay lean, calorie restrict even if you're strong enough to do that. The body has these inbuilt pathways that turn on the defenses that take care of seemingly all the major causes of aging. How do you mimic that in a pill? That's the challenge. And some of the pathways that we work on, there are these genetic pathways like sirtuins, there are others called mTOR, AMP kinase, but there's a network that controls our body, and some of the molecules that I work on kick the body into that defensive mode and get the body back to a youthful state and into that defensive mode without necessarily having to run a marathon every few weeks or stay super skinny and hungry.
I would say that the best kind of insurance policy you can have in the future is to start aggregating and tracking data about yourself, because you know something is going to go wrong, like death and taxes, they say, those are the two things that are guaranteed. So you're going to have a health incident. The question is what information are your doctors going to have at their disposal to determine what's wrong with you? And even if we don't know what to do with it right now, technology is changing and our understanding of human biology is changing, is advancing so fast that we will likely by the time something is wrong with you. So build a time capsule of information and continually deposit to it. And you don't even have to look at it right now. Save it for a rainy day.
And you do that with devices, with monitoring, with what kinds of ways do you collect that information?
There's just simple, even just starting with tracking your pulse and your activity. Like that's a huge increase from 0 to 1 even.
Yeah.
But, I regularly get a number of clinical assays done to track changes in my biochemistry. And I think there's more and more services that are making that cheaper and cheaper. And it's not necessarily for everyone yet, but I think it will be.
So this is going to sound strange, but I've been experimenting on myself and by demand on my family for the last decade.
Wow.
So I have a fair amount of data. On one side, we do a bio-tracking. And so I've seen my calculated BioAge go up dramatically, scarily so. About 3 years ago, it went up to over a decade older than my actual chronological age. I was sitting around and not watching what I was eating. And so then I took action. I took metformin, Kristen mentioned, which is a diabetes drug. I took another molecule that we've worked on called, it raises NAD. We call them NAD boosters. And I saw that my BioAge, according to this algorithm, went down to 31.4 from 57 point something. And I've stayed down there. So that's been a dramatic improvement in biomarkers. And if I hadn't been monitoring myself, I would have had no idea. My physician wouldn't have said anything. I was still within the normal range. But it's crazy to let us become diseased before we take action. Often it's too late. My father's 78. He's running around like he's 25 again. He says he feels great. He feels better than he ever did. He's dating my ex-girlfriend. He's having a great time. I'm okay with it. My wife feels a bit strange about it.
Good. Thank you so much. Hopefully we're here in 60 years still talking about this due to all the work you're doing.